So after understanding the concept of correlation, let's start with the numerical questions. We can say algebraical method of calculating correlation. So first method we are understanding is Karl Pearson's coefficient of correlation. So, this method, Karl Pearson coefficient of correlation, is widely used mathematical method, we can say, where we can express the correlation among the variables in numerical form. So, basically, this method of calculating correlation is given by Karl Pearson. So that's why it is known as Karl Pearson coefficient of correlation, which is mainly used for the numerical expression in use to calculating the degree and the direction of the relationship between the variables to check the linear relationship among the variable. So Pearson's method is most popularly used method while calculating the correlation. Talk about the benefit of using Karl Pearson's coefficient of correlation. We can say that this method is used for mathematical calculation of a correlation among the variable, as it is widely used method among the researcher for calculating the correlation. We can say that it explains both the degree and direction of correlation very clearly and very precisely. So, in coefficient, Karl Pearson coefficient of correlation, the coefficient of correlation is denoted by R. Okay, is denoted by R in coefficient of. It is denoted by R, and it is basically calculated on the basis of mean and standard deviation. When we do the calculation of Karl Pearson coefficient of correlation, the coefficient of correlation is calculated on the basis of mean and standard deviation. So the calculation of mean and standard deviation we have already discussed in our previous chapters. Okay, so it is obtained basically by dividing the sum of the product of the corresponding deviation of the various item of two series. So when we start with the calculation of Karl Pearson of, so as we can say that when we start with the calculation of Karl Pearson of coefficient, we will see that there is two series given in the question. As in correlation, we are going to study the relationship, or we can say the relation among the two variables or more than two variables. So if we talk about the formula of calculating Karl Pearson of correlation, so the formula is written on your screen. As I have already told you, the coefficient of correlation is denoted by R. So R is equal to sum of dx and dy divided by n into standard deviation of x and standard deviation of y. So we also denote standard deviation with sigma. Okay, we have already discussed this point in previous lectures, that standard deviation is also denoted by sigma. So we can also write this formula as sigma dx dy divided by n, which is the sum of a series, into sigma x into sigma y. So this is the formula of calculating Karl Pearson coefficient of correlation. Okay. So So as I have told you that for calculating coefficient of correlation, we have to first calculate the mean and standard deviation. So as this is the formula, sigma dx dy divided by n into sigma sum of dx dy divided by n into sigma x and x sigma y. So first of all, we have to calculate the value of x. So value of x is calculated by x minus x bar. What is x bar? So x bar is the mean. X bar is the mean. And if when we have to calculate the value of y, so y is equal to y minus y bar. Okay. So in a given question, we have two series x and y. When we do the calculation of correlation, we have given two series x and y. So first of all, we have to calculate the mean of x, and then we have to calculate the mean of y. As x bar is the mean of x and y bar is the mean of y. So for calculating x, the formula is x minus x bar, and for calculating y is equal to y minus y bar. Okay, n is the number of observation. Okay, it is number of observation. Understood? And if we talk about this sigma x, so what is sigma x? So sigma x is standard deviation of x. Okay, it is standard deviation of x. If we talk about sigma y, then sigma y is standard deviation of y. What is this? Standard deviation of y. So now we already know how to calculate the value of r. So the basic formula is for calculating the value of r is sum of dx dy upon n into standard deviation of x and standard deviation of y. So first of all, we have to calculate the value of x, value of y. So for calculating value of x and value of y, we have to calculate the mean for both the series. Then n is the number of observation, and sigma x is standard deviation of x, and sigma y is standard deviation of y. So this is how we calculate this r, and we can also say that this is the equation or the formulation of equation. Okay, so the which we have discussed, this is the formulation of the equation of r. Okay, now so we the first method of formulation of equation of r we have already discussed. So we can say that the second formulation, we can say that this sigma dx dy is also known as covariance. Covariance, as we have written here. So covariance basically sum of dx dy divided by n. Okay, so this is how this formula works. Let's understand with some numerical question the formulation of this formula of Karl Pearson of coefficient. Let's understand with some numerical question. So let's solve the question number 1, as there is information given in this question that from the values which are given below, we have to find out the coefficient of correlation. So there are 4 points are given in this question A, B, C, D, and some information are given in these questions. So we have to calculate this Karl Pearson of correlation, which is denoted by R. We will calculate for all the points. First one is A. We have to calculate the value of R, which is coefficient of correlation. So in part 1, the values which are given is sigma dx dy, which is 150. Value of n is given. Standard deviation of x and standard deviation of y is given in the question. So what is the formula for calculating this R, or you can see coefficient of correlation, is sum of dx dy divided by n into standard deviation of x and into standard deviation of y. So sum of dx dy is already given in question, which is 150 divided by 9, which is number of observation, multiply by deviation of x, which is 5.8, and deviation of y, which is 3.2. So now with the help of calculator, we calculate this problem. So first of all, calculate the lower value 9 multiply by 5.8 and again multiply by 3.2. So the answer is 167.04. So 150 divided by 167.04. So now again let's do the divide part, which is 150 divided by 167.04. So the answer is 0.89. Okay, so the answer is